as we consider these evidences from nature, we also have to have in our minds, in the background, we need to have the view or the hypothesis or the belief of people who don't believe in God. So atheists, that is people who don't believe in God, believe that the universe came into existence on its own, and they believe that life also has evolved. They believe that inanimate matter came together, there were some chemical reactions between water and some other compounds, and then the first cell was formed, and then the cell multiplied, reproduced, and then it evolved, and it became into everything that we see today, including humans. This is the belief of people who are atheists. Now, this theory, the theory of evolution, it states that the extinction and the evolution or the change of organisms is guided by a principle called natural selection. Now, natural selection is something like this. There are these genetic changes called mutations that take place in organisms. So, when two parents produce an offspring, the genes of the offspring are slightly different from the parents. So, you have so many offspring which are slightly different. And then the theory says some of these are better adapted to survival, and they survive and others become extinct. And so whatever traits or whatever qualities are helpful for survival, those are the qualities we are likely to see in organisms all around us. This is the theory or the belief of atheists. So it's helpful to have this in mind as we consider these evidences for God. Now this is a picture of lobster eyes. Lobsters are a creature in the sea, and these are their eyes. And this is NASA's X-ray telescope. Okay, so why am I showing them in the same slide? Because NASA made their X-ray telescope by looking at the eyes of the lobster, getting ideas for the design from the eyes of the lobster. So this is a common theme in engineering. You look at nature and then you see the things, the systems that are there in nature. That is an inspiration for man to make machines on his own. Now, when human beings make something, there are a lot of engineers working on it, a lot of intelligence goes into it, a lot of thoughtful planning, a lot of intelligent exercise goes into it. And if these things require so much of intelligent effort, it is only logical to conclude that the inspiration for them, what we find in nature, like the lobster's eyes, that also must have required a lot of intelligent planning. Are you getting the analogy? Okay. These things in nature are an inspiration for man to make machines. So if these machines require intelligence, it is logical to conclude that these systems in nature also would require intelligence to make. So we look at some of these features. When we look at nature, we see sophisticated systems. Okay. Here is one example. Look at some of the equipment that a bee has. Bees have airspeed gauges. That means they have something inside them which gives them an indication as to how fast they are flying or how fast is the wind around them. Okay. Then they have gyroscopes. Now, gyroscopes are used in aircraft and ships and spacecraft. The purpose of a gyroscope is to maintain its orientation. Like suppose we have a table in this room, but suppose this was a ship. Then as the ship moves in the water, the whole room will tilt. And so if something is kept in the room, it will also tilt. But suppose we wanted some equipment that always has to be vertical. So even when the ship tilts, the equipment must still remain vertical. Now that can be accomplished with a device called a gyroscope. Now bees have got gyroscopes inside them. Then the bees have a very short range vision. So they cannot see the position of the sun in the sky. They cannot make out whether the sun is overhead or whether the sun is near the horizon. So, which would mean that they wouldn't be able to make out the time of the day in that way. Like we can understand if it's evening or noontime or morning by looking at the position of the sun. But bees cannot look at the position of the sun. But there is something else they can make out. They can make out the polarization of sunlight. Now, light has a quality to which this polarization is related. Light is a wave. So you imagine a wave can go up and down like this, Okay, a wave can also go like this. So which way is light going? We cannot see, but bees can make out. Okay, so if the light is in a particular fashion like this, I would say it is polarized horizontally. If light is going this way, it's polarized vertically. A water wave always goes like this. A water wave never goes like this. But light can go in any direction. So light can be polarized. And bees can detect the polarization of sunlight. And that is how they detect the orientation of the sun. Okay. They have got ultraviolet sensors, so they can sense even UV light. We human beings can see from red to violet. So bees can sense little more than violet. They have got 2 compound eyes. Compound eyes means eyes with multiple lenses. Human beings have 1 lens in their eye, and bees have got multiple lenses in their eyes. So they have got a very sophisticated eye. This is a close-up of the eye of the bee. So it's got many small panels. There are around 7,000 panels in the eye of the bee, and each one has to be at a precise orientation for the bee to see properly. Right? Now, to make all these things would require a lot of effort. It would require a lot of intelligent design. If we were to make a camera having 7,000 lenses, okay, that would require a lot of intelligence. Therefore, it seems appropriate to conclude that a creature like this must have been designed by somebody. That somebody is the creator, that is God himself. This is a picture of bacteria, and these bacteria have some threads coming out of them. So that thread is called a flagellum. So after scientists made microscopes, they could get into the details and see these flagellum in detail and find out their internal structure and so on. So there are many things to learn about it, but I am emphasizing the fact that the flagellum has high performance. So the purpose of the flagellum is this thread rotates, and as the bacteria is swimming in the water, the thread rotates, and in this way the bacteria is propelled forward. So it's like the rudder of a ship. It's got many components. It rotates at a speed of up to 1 lakh rotations per minute. Okay, if your car has a tachometer, you will see the RPM there. So for a car, it's typically between 1000 or 2000 RPM. But this rotates at 1 lakh RPM. Then it has a capability of reversing its direction within 1/4 of a turn. In a car, you cannot quickly shift into reverse gear. You're going fast, you can't suddenly reverse. You have to stop the car, and then slowly you have to go into reverse gear. But this one reverses its direction very quickly. Okay. And then it enables a cell to move at a speed of 35 cell lengths per second. So imagine a car that is traveling around 70 or 80 meters per second. That is really fast for a car. Right? If you're wondering what meter per second is, 36 kilometers per hour means 10 meter per second. So if it's 70 meters per second, it's like 200 kilometers per hour. So imagine a car that is going at 200 kilometers an hour. So considering how small the bacteria, that's an idea of how fast the bacteria can travel because of this flagellum. So this is a device which has got a lot of components in it, and it has got a high performance. Okay. It does not seem likely that a device like this would be the result of mutations, that is random changes in genes when a parent gives birth to an offspring. Okay. Now today we know that all creatures have got genes, that is DNA, and the DNA contains instructions or a blueprint for all the parts of the body of the organism. So if you imagine an app on your phone, it requires it requires a code. It's a software. It is programmed. So there are so many, perhaps there are 100 or 1000 lines of code that are used to write an app, to make an app. So each of these components would also require a large amount of genetic code. So some intelligent person has coded everything, coded the instructions, and enabled these things to be manufactured. And all this is very small in a bacteria. So this is another picture of the same thing. So this bacterial flagellum is one example of a high performance device in nature. And that again suggests that nature has been intelligently designed. There must be a creator who has thought of all these things. Now, as I said, in the background, we have this view, this atheistic view, that all these creatures have evolved. They have just come about due to random mutations in an attempt for in a struggle for the survival of the fittest. Okay, but as we will go along, we will see that many of these things are not required for survival. You know, the bee flies in a very complicated way. A bee did not have to be so sophisticated in order to survive. Okay. The bacteria did not have to have such a high performance device to survive. There are other microorganisms which don't have this flagellum and they are surviving very well. Okay. So the evolutionary idea that everything has come about in an attempt just to filter out traits in an attempt for survival of the fittest, that does not sound very logical. Okay. We have so many systems and parts of organisms in creatures that do not seem to be necessary for survival. Now, I consider this as one of the most important of all, and this is easy to explain if you're in a conversation with somebody. In our body, in our cells, there is software. There is some information content. And I'm referring to the DNA. So here's this quote from Richard Dawkins, who's one of the outspoken atheists today. He says like this: there is enough information capacity in the DNA of a single human cell to store the Encyclopedia Britannica, all 30 volumes of it, 3 or 4 times over. So in this DNA is like a long piece of paper on which things can be written, or it's like a very, very big hard disk on which many things can be stored, and they are stored. What is stored in the DNA? All the information about how this organism is supposed to develop. So when a baby is just the first cell, that first cell has the DNA inside it, and the DNA contains instructions to make hands, to make legs, to make an eyes, nose, ears, etc. Some people have black hair and some people have brown hair. The reason for the difference is the different kinds of instructions that are there in the DNA of different people. So all this is coded. Okay. So if someone has produced, if there is an Encyclopedia Britannica in front of us, we don't think that, you know, some ink got spilt and that's how this whole encyclopedia got written. Okay, even if that happened, how did the ink know that it had to write it in English and not in some other language which nobody can understand? Okay, we don't think that such a thing could have happened. So in the same way, when we look at living things and we see this amount of information and software in them, it is logical to conclude that these have been designed by a creator. Now, atheists believe that there was inanimate matter and chemical reactions took place and then the first cell was formed. But the fact of the matter is this, that chemical reactions never produce information. No matter what you mix up in the test tube, India's history struggle, independence struggle is not going to come out of that. The story of India's struggle for independence is an example of information. It can be stored on paper, it can be stored electronically, it can also be stored on DNA, if someone could write on the DNA. Okay, but it does not come about by chemical reactions. Information always originates in an intelligent mind. Since the human cell contains information, it is logical to conclude that it originates in the mind of a creator. Okay. I think in 1 or 2 sessions earlier, when we were looking at different logical errors that make, one of the examples that I had was called storytelling. And I quoted from the same person who has written a book called The God Delusion. And in that book, he was talking about the origin of life. And there I had highlighted so many speculative terms that he used, probably, maybe, some kind of, perhaps, So many speculative words were used in his description of the origin of life. So scientists are talking about it, and most biologists don't know much about information theory. So they keep looking for, keep discussing ways in which life must have originated, but it never happens in the lab. It never happens in reality. Now, it's not that we are working on it and someday we'll figure it out. We already know that chemical reactions never produce information. Organisms contain information. Therefore, organisms have not arisen through chemical reactions, but by the action of an intelligent creator. So here's just another diagram which is showing the DNA. So in the body there are cells. Inside the cells there are these chromosomes, and the chromosomes contains genes. So it's like a very long sheet of paper on which so many things are written. Everything about my body is written on this. Okay. Then there's an interesting characteristic in nature called irreducible complexity. Okay. The meaning of irreducible complexity is the characteristic of a system such that even if one of its components is not functional, then the whole system fails. Imagine a system which is such that even if one component is not working, the whole system will fail. Now, why is this kind of a characteristic important? Again, as I said, the atheists believe that evolution took place in slow, gradual processes. So, bit by bit, organisms gradually changed, and they developed various features. The process has to take place bit by bit, and every bit is favored only if it helps survival. But what if you have a system which does not help in survival at all unless all the multiple things are working together? Such a system could never be built by evolution. That's why this characteristic is very important. Okay, I'll say it again. What we mean by irreducible complexity is a system which is such that it will fail completely if even one of its components is faulty or absent. It requires multiple components present simultaneously to work successfully. According to evolution theory, every system that we see in organisms developed very slowly, step by step, and only those steps were favored which help survival. So imagine a mechanism which has 20 components. Component number 1 is formed by a mutation, but it is useless by itself. So it will not survive. The creature with that feature, that characteristic, will not survive. Component number 2 is formed. It's of no use to the creature acting by itself. Component number 3, even if it is formed by a mutation, no use. All 20 components have to be there simultaneously, and all of them have to work together. Only then the system succeeds. So there are many examples of this, but here is one of the simple examples, and that is a woodpecker. The unique thing about a woodpecker is that it bangs its beak or it bangs its head into trees. Now, according to evolution theory, all birds have a common ancestor. And once upon a time, those ancestors never banged their heads upon trees. So, one fine day, some of those birds must have felt like banging their head on the tree. Why? That is a question that has to be answered. Now, if you bang your head on a tree, you will enjoy yourself. The woodpecker has got special shock-absorbing tissue. So it has an instinct that other birds don't have to bang its head into the trees. Then it has a shock-absorbing tissue, again something which other birds don't have. Then, what is the purpose of banging its head into trees? It opens out the outer layers of the tree, the bark, and underneath the bark there are insects that are there, and that is the food for the woodpecker. But as the woodpecker pecks on the trees, the insects try their best to go deeper and deeper inside. So imagine, according to evolution theory, one of the ancestors of the birds banging its head into the trees. It wouldn't get any food to eat because the insects would go further inside. But the woodpecker has got a very long tongue, and it puts out the long tongue, which other birds don't have, and then it takes the insect. But of course, that requires a special adhesive. The tongue of the woodpecker is very sticky, and when it puts out its tongue and touches the insect gets stuck to the tongue, and then the woodpecker drags it back into its beak. How is a long tongue going to fit inside a beak? A woodpecker has a special arrangement in which the tongue is coiled up inside the beak when it is not in use. So the point is, this could not have developed in small steps. Am I making myself clear? This system is such that even if one component is not developed, the whole thing fails. So it has to be developed all at once. But evolution cannot take place all at once. Evolution is supposed to take place in slow stages. This suggests that there was a creator who created everything all at once. He made the woodpecker with an instinct to bang its head into trees. Then simultaneously, he also provided it with a shock-absorbing tissue in its beak. And then simultaneously, he also provided it with a long tongue, which is sticky. And he also provided it with a coiling arrangement inside its mouth so that it can store its tongue when not in use. Examples like these suggest that these systems did not develop gradually by evolution. They have been designed all at once by somebody. That somebody is God, the creator, the one who made everything. Yeah, so that concludes our discussion of these design features. In this context, there are certain words that are used. Order means some regularity in arrangement. There is an order in nature that we see. Okay. But order by itself is not very remarkable. Like if you see a crystal of sugar or something, you will find that all the small particles are arranged in order. So order by itself is not very remarkable. Then there is something called complexity. Complexity means something is very complicated. If a child scribbles on a piece of paper, that will look very complicated. So complexity by itself is not remarkable. But what is remarkable is ordered complexity. Okay, a crystal is ordered and a child's scribbling on the paper is complex. Okay, but an aircraft has ordered complexity. In the aircraft, there are many components that fit together in complicated ways, and they all work together to serve a common objective. That is ordered complexity. Now, ordered complexity suggests that a designer was involved, and we see ordered complexity in nature, and that suggests that nature has a creator. Okay, so this is one category of evidence from nature for God. Okay. Yeah, there is another interesting characteristic in nature called fine-tuning. Okay, first we'll understand what this fine-tuning is. Now this is Christopher Hitchens. So he is also one of the most outspoken atheists in recent times. He's passed away now, but he's written a book called God is Not Great, How Religion Poisons Everything. So he's a very outspoken atheist, and he somehow wrote a book together with a pastor called Doug Wilson. And he in an interview, he says like this: we, that is the atheists, are all asked which is the best argument from the other side. And I think every one of us picks the fine-tuning one as the most intriguing. So here's an atheist saying that out of all the evidences that people claim is there for the existence of God, this is the one which is the most intriguing. That's what this atheist is saying. So let's understand what this fine-tuning is. Every system has some parameters that define its state. For example, if a car is being driven, one of the parameters is the speed, which gear we are on, the windows can be closed or the windows can be open, the AC can be on or off. So these are parameters. What is the speed? What is the gear? What is the status of the windows? What is the status of the AC? By using the green color, I mean to say that these are good values of these parameters. If you're driving your car like this, that is quite fine. The car can function well. Instead of 100 kilometers per hour, if you go on 80 kilometers per hour, that is also fine. I mean, the fifth gear will still be fine. You are still okay with the windows closed. If you go at 80 kilometers per hour with the windows open, with the AC off, that's also manageable. It's still possible. So what we are seeing here is that there is a wide variation in the values of the parameters and the system still works fine. Now, if you change it like this, 30 kilometers per hour, fifth gear, most cars would stall. So you cannot go 30 kilometers per hour on fifth gear. So there is a wide range of variation such that the car works fine. Okay. Now, fine-tuning is the opposite of this. Fine-tuning means that the system will fail if its parameters are changed even slightly. I hope I'm making the point clear. Okay. So every system, a car or the human body or any machine, it has some parameters. Okay. And a fine-tuned system means a system in which a slight change in the parameters would result in disaster. So the parameters have to be very precisely set in the right way for the car to for the system to function. Imagine you had a car. If you drive at 100 kilometers per hour, it's fine. But if you drive at 99 kilometers per hour, the car gets damaged. That would be an example of fine-tuning. Okay. Now, gradually, in the last 100 years, scientists realized that the universe also has got parameters. And the universe would be different if the parameters of the universe were different. Okay. So, these are some of the parameters that are there in the universe. Of course, it looks very complicated, but perhaps all of us know what is meant by the speed of light. How fast does light travel? Nearly 2 lakh kilometers per second. If the speed of light were different, then the universe would have been different. Okay. Now, if you imagine God is creating the universe, then God has to decide if He's making light. How fast should I make light travel? That's a parameter for Him to set. Okay. Then the gravitational constant tells us how strong gravity is. So you can imagine if an angel were to assist God in creation, then the angel would ask God, should we make gravity this strong, or should we make it more stronger or less stronger, or what? What is a suitable level of gravity that we should have in our universe? So if you are making something, you will set the parameters. The universe also has got certain parameters. So there is a long list with many values. These things like electron, proton, neutron, and all, these are small particles that are there in the atoms. And all these constants, they talk about certain forces and all that are there in nature. Here is another example. Someone has made an image like this, and God said these things, and there was light. The reason someone made the image that way is that these are the equations that describe light. Okay. So all these equations involve abstract mathematical concepts, but anyway, that's not our subject right now. In these equations, there are some parameters. This parameter tells us how strong electricity is. If its value were different, electric shocks would be more severe or less severe. Current would go faster or slower. This quantity has to do with magnetism. If its value was different, then magnets would be stronger or magnets would be weaker. Okay. And this is the speed, the c is the speed of light. So these parameters come in the equations. So the universe has many parameters, and in the last few decades, scientists found out something interesting about these parameters. The scientist's name is Stephen Hawking. He is also an atheist, and he has written many books. His most famous book is called A Brief History of Time. And he writes like this: the remarkable fact is that the values of these numbers, that is the constants of physics, that is these parameters, they seem to have been very finely adjusted to make possible the development of life. So he's saying that if you look at all those numbers in the previous slides, if those numbers were slightly different, if the value of C or G or those things that we saw, if it was slightly different, then life would not have been possible. So he explains like this: if the electric charge of the electron had been slightly different, then stars would have been unable to burn hydrogen, that is, stars would have been unable to shine. It seems that there are relatively few ranges of values for the numbers that would allow for development of any form of intelligent life. Most sets of values would give rise to universes that, although they might be very beautiful, they would contain no one able to wonder at that beauty. So if those numbers that I showed earlier, if these numbers were slightly different, then perhaps the universe would just be a cloud of gas. Okay, it would not have any stars, it would not have any planets, it would not have any people. Then Stephen Weinberg is another scientist. This person is a Jew, a Jewish scientist, but he's also an atheist. And he writes like this: how surprising it is that the laws of nature and the initial conditions of the universe should allow for the existence of beings who could observe it. Life as we know it would be impossible if any one of several physical quantities had slightly different values. So he's saying that if the universe's parameters were slightly different, life would not be possible. And he gives us one particular quantity. Its value has to be precise to about 120 decimal places. Okay, so imagine a car that you have to drive it at 56.000000120 zeros and 1 kilometers per hour. And if you drive it at 56.0000120 decimals and 2 kilometers per hour, then the car would not function properly. That is how the universe is. If its parameters were slightly different, we would not exist. Then there is Fred Hoyle. So Fred Hoyle was an atheist, and then he slowly came to some sort of belief in a creator. And he is from Cambridge, and Cambridge University, and he has done a lot of work to understand how stars function, how do stars shine. And he says like this, that a common sense interpretation of the facts suggests that a superintendent has monkeyed with the physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature. He says the laws of nuclear physics have been deliberately designed with regard to the consequences they produce within stars. So he says the rules of physics, if they were slightly different, then stars wouldn't be able to shine. So it looks as if somebody has decided these things very precisely, and that's why the universe exists the way it is. Now, just as the universe is fine-tuned for life, the earth also is fine-tuned. The earth has got many special features. So we look at some of these features. Okay, where are we in the universe? The earth is one of the planets in the solar system. So all these planets revolve around the sun. Okay, but then we can ask, where is the sun? The sun is part of the Milky Way galaxy. So this is a huge collection of stars, 100 billion stars. And the Milky Way is so big that it would take light 1 lakh years to travel from one end of the Milky Way to the other. That's how huge the Milky Way is. Okay. Remember that verse in Romans 1:20, it says, the attributes of God are visible from the nature. So once you understand that there is a God, that God must be very big and powerful if he can make things like this. Okay. But anyway, that's not our subject right now. Where are we in this Milky Way? You can see this spot here. That's where we are. So this is a close-up of that region. So the entire solar system is a small dot in this big diagram. Now, this is a very special place to be in. One of the reasons it is special is that it is far away from dangerous stars. There are some stars that are dangerous. You must have heard of black holes. Black holes are there. Then there are some stars that emit powerful radiation which is dangerous. So the Earth happens to be far away from any of such dangers. Okay. Then another wonderful thing about the Earth, this is not for safety, but then it's a nice thing, is that the Earth is in a part of space which is very clear. You know how boring the night sky would be if the Earth was in one of the dusty regions of the galaxy. So it looks like God not only gave a safe place for the Earth, but He gave a convenient place for the Earth from which man could be able to observe the universe properly, because the universe exists for God's glory. So God wants man to find out about the universe. If we were in one of the dusty regions of the galaxy, then we wouldn't be able to observe the distant universe. Okay? So we are in a very special place in the galaxy. Then, in order to have life like we see on Earth, the planet has to be a rocky, solid planet. Not all planets are solid planets. Like there are some planets, like in our own solar system, there is Jupiter and Saturn. These are gas giants. They're just a ball of gas or liquid. Okay, so such a planet cannot support life. Okay. Then this is a picture of a comet which is going around the sun. Okay. Now this orbit is oval shaped, which means that sometimes the comet is very far away and sometimes the comet is very close to the sun. Now this is a similar diagram, if the Earth had this kind of orbit, then it would not be nice. Can you understand? When we go very close to the sun, the summer would be very, very, very hot and the winter would be very, very cold. Okay. But our Earth has an orbit which is almost circular, which means that the Earth is almost at the same distance all the time from the sun. Okay, still we find it difficult to cope with the cold and the heat. Okay, when the orbit is almost circular. But there are many planets that have a very eccentric orbit. So this has been carefully designed. Then of course you shouldn't be too close or too far away from the star. So on the right corner we have the star. If the planet Earth or whichever planet was very close to the sun or the star, then it would be too hot. And if it is too far, then it would be too cold. So there is a narrow region in which the temperature is just right to have liquid water and thus to support life. So the Earth is in a narrow band of distance from the sun. If the star is a very powerful star, then you need to be further away to be safe. If the star is a very weak star, then you need to be closer to be warm enough. Are you understanding this? Now, one interesting question to ask is that on an average, are the stars stronger than the sun, like more powerful than the sun, or are they weaker than the sun? Okay. It turns out that most stars are much weaker than the sun. So this diagram tries to show the population of stars. So most of the diagram is red. In other words, most stars are what is called red dwarfs. They are small and they are not so powerful, not so bright. The sun comes in that brown yellow category. The blue stars are the blue represents the most powerful, highly radiant stars. You'll have to be very far away from them to be safe. Okay. Now, if the sun was a red dwarf, so as I said, the sun is that brown yellow region, that kind of star. If the sun was a red dwarf, then in order to be warm enough we would have to be close to the sun. But it turns out that if you're close to the sun, so this is an example of the above diagram, is an example of another solar system which is much smaller than our solar system. See, this is our solar system. And the other solar system is so small, it fits in this region only. Okay, because that star is smaller. But it turns out that when you are too close to the star to be warm enough, there's something called tidal locking that takes place. That is, the planet starts rotating only as fast as it revolves. The Earth rotates and the Earth also revolves. But when the planet gets tidally locked, that means it rotates only as fast as it revolves. That means 1 day and 1 year are the same. That means there will be daytime for 6 months and nighttime for another 6 months. 6 months of daytime would be too hot to cope with. Okay, so if most stars are small, in order to be warm enough, you have to be close by, but there you have another problem. That is tidal locking. And you have 6 months or half a year of nighttime and half a year of daytime. So that's not helpful. Then another important thing is a large amount of water. Most planets don't have water. The Earth has huge amounts of water. Then this is the Earth and the Moon shown to scale. You understand what scale is? I mean, if the Earth and Moon were shrunk this much, this is how far apart they look. Okay? And compared to the Earth, the Moon is of course smaller than the Earth, but it is not so small. There are other planets whose moons are very small compared to the planet. But Earth's moon is not so small compared to the Earth. Now, it turns out that helps the Earth's axis to have a stable tilt. You know, the tilt of the axis of the Earth is responsible for the seasons. Okay? If the axial tilt was not stable, then the seasons would go haywire. Like suppose the axis tilt becomes more, then summer would be hotter and winter will be colder. If the axis tilt becomes less, then summer and winter will become almost the same. Okay, so the Earth has a stable axial tilt. Then there are different layers in the Earth. So in the Earth, the topmost layer is called the crust, and the crust has got the right thickness to provide stability for the Earth. Yet another feature, this is called northern lights or Aurora Borealis. So this is a phenomenon which is seen in the northern countries or near the poles. So there you see that the atmosphere seems to be lit up. So what is happening is that there are these particles emitted from the sun, and these particles are dangerous particles and they are coming towards the Earth. And the Earth has got a magnetic field. So the magnetic field deflects the particles, and instead of falling all over the Earth, they fall only near the poles. So they are concentrated in one place, so they do not cause harm all over the Earth. So the Earth can do this because the Earth has got a magnetic field. So the Earth is like a big magnet, and the Earth manipulates or diverts these particles, and they all go only on the poles of the Earth. So if the Earth did not have a magnetic field like this, then these particles coming straight from the sun, they would come and they would perhaps fry our electronics, and they would cause cancer when they hit our body and so on and so forth. So the Earth has this protective feature. Then in the outer region of the solar system, there are these big planets. Okay. And this is not completely understood, but some scientists feel that these big planets are playing an important role. There are these stray objects and comets which are coming from outside the solar system. Like this is a series of photographs of a comet. And because Jupiter and Saturn are big, they have a powerful gravity, and they attract these objects towards themselves. So they are like a shield for the Earth. So there are these stray objects coming in from outside the solar system. There is a possibility that these objects might collide with the Earth. That would result in disaster. But you have these big planets in the outer regions of the solar system, and those planets attract these objects and so serve as a shield to the Earth. So there are so many different features of the Earth that make life to be possible. But even more powerful than this, I think, is the earlier argument about the fine-tuning of the parameters. They have been chosen very, very precisely, and that suggests that there was a creator who decided these parameter values very carefully and very precisely because he had a purpose. He wanted the universe to support life, and so he chose these parameters very clearly. Okay. So these were some arguments. There are more, but these are some arguments from nature which point to the existence of God. Looking at the nature around us, it seems as if there is a creator who has created the world. And if there is a creator, then you better find out who he is and what he expects from you, right? A creator calls for accountability. We need to know who he is, what he has to tell us, what he expects from us. And for those of us who believe in this creator and believe that it's important to know him, may the knowledge of these characteristics of nature encourage us to share it with others also, and help them to understand that there is a creator. Sometimes we use the word primary revelation and secondary revelation. So nature is called primary revelation and scripture is secondary revelation. That is, nature can only tell us some things about God. Galileo was a scientist, so he used these words. There are two books from which we learn about God. One is the book of nature, and the other book is the Holy Scriptures. Okay. So there are some things that we learn from nature about God. We learn that he is big and powerful, and he is intelligent, and he is creative, and he is a great designer. The Bible tells us a lot more about God. But may God help us to proclaim the good news about him.